Hey guys, welcome to Advent of Code Day number 6. Now, guys, I already solved this challenge, but I'm just gonna be walking through my solution. So let's see. So we're given a map with a guard with this caret symbol that I'm highlighting right here, and we're supposed to, for part 1 of the challenge, we're supposed to move the guard forward whenever there isn't any obstacles or obstructions in its ways. So obstructions are represented by this hash symbol, and whenever our guard is not is facing up, for example, and there isn't any obstructions in its way, then it just continues moving forward. But whenever it hits an obstacle or obstruction, it makes a 90-degree turn to the right. So you can see they're saying it, if there is something directly in front of you, turn right 90 degrees, otherwise take a step forward. And you can see, guys, the guard is moving up. It hits this obstacle, so it goes right to the next obstacle. And this process just keeps repeating until it reaches the end of the map. And then for part 1, we're supposed to figure out how many distinct positions will the guard visit before leaving the mapped area. So let me walk you guys through my challenge 1 solution. So here's how I did it, guys. So I first parsed the file. So I got the puzzles. I got the puzzles, guys, and we're supposed to parse our file. So I first read each line in the files, and by using the fscanf function in C, and while we're not at the end of the file, we just get the length of that buffer. So this modulus ms conversion specifier just dynamically allocates our buffer. So you can see our buffer is represented as a char pointer, and we pass that pointer as a reference to our fscanf function so that it can be allocated dynamically while fscanf is parsing or reading our file line by line. And then, guys, we say if we need to get our column size, because this map can be represented as a grid. So therefore, we get our column size, and it's just gonna be the string length or the length of the buffer. And because each dimensions within our map, if we think about it as a 2D array or a square matrix, all of the dimensions are equal. So therefore, we just get the length of one of the column size of one of the lines, and we also, meanwhile we're reading, guys, we try to find the starting position for the guard. So I have a variable up here called found guard, and I set it to false. So while iterating, I say if not found guard, which will just inverse this boolean thing, flag that we set to false, which will become true. and then we then iterate through our column size that we get, and then we check to see for each character in our buffer that we read, or the line that we read, is equal to a caret symbol. Then we set the guard row equals to the map count. So it's 0 indexed base, so we just set it equal to our map count. And then we set our guard column to equal to the index, or the index of the character that we found. Then we just set found guard flag equal to true. So next time when it's iterating, guys, this block of code that I'm highlighting doesn't get execute. Then I just append each buffer in our string list that we implemented in the last video, guys. And then we just free the buffer since we allocated memory from it for it in the fscanf function. Then now, guys, I essentially define an integer, which is a two-dimensional array, which consists of 4 directions. So we can move up the guard up, right, down, left. So if you guys think about it like this, let's say we have something like this. So let's say we have a matrix like this or something like that. In order to move up, in C, since our indices start at 0, we would have to decrease our guard position or guard row, while the column that we're at would remain constant. But if we're going right, then we just increase our guard column. Otherwise, if we're going down, we just increase our guard row while the column remains constant. And if we're going left, we just decrease the guard column while the row remains constant, which is 0, you know. So guys, I then define a variable called current direction, which will keep track of the direction that the guard is visiting, or the current direction of the guard. Then I append the starting position of the guard, since they ask us this question: how many distinct positions will the guard visit before leaving the mapped area? So I append the guard row, which is the starting position for the guard, and the guard column to our list. And then we create a while true loop. We say I define 2 variables, one called incrow, one called incall. And then we just index or directions array at our current direction, and which we essentially pick our row, the amount that we want to decrease or increase our row by, depending on the direction, if we're facing up, right, down, or left. And we also do it to get the amount that will increment our column by. Then, guys, I say if our guard row plus the inc row is less than or equal to the map.count. So what this means, if the guard goes to the edge of the map, like let's say the guard is here where I'm highlighting, guys, then where I'm highlighting right here, then it would mean that we finished the map, or the guard left the map. Or if the guard is at this edge, then it would mean the guard left the map also. And we check if that particular guard row, guys, at that particular guard column, whenever we increment, is equal to this hash symbol, which is one of our obstruction, right? And then we just actually increment our guard row by the amount that we should increment by. And then now, guys, we define a boolean called visited so that we don't add the visited positions multiple times to our list. So this way we can keep track of the distinct positions. Now, because I store each positions like this, like this, like 1, 2. I just append the row and the column beside one another in our list. This is why I increment the visited in the I by 2. So I check if the visited position at array index I is equal to the guard row that we got, and we say if the next index is equal to the guard column, then we set visited equal to true. Then we just break out a for loop. Then we say, after we have breaked out of the loop, or we are finished with the loop, we check if this visited flag is not set to false or is not set to true. Then we append our new visited position to our list. And then now, guys, we check to see if the guard row is less than or equal to 0. That means our guard has left the map. Or if our guard row is greater than or equal to the map count minus 1, and vice versa for our column as well, then we just print the total number of distinct positions, guys. So we divide our visited positions length by 2, since we're appending 2 items each time, which is the row and the column in our list. So let me show you guys. So when we run this code now, you can see we get 4,663 positions. And that was my answer. And for part 2, guys, all it asked for was to place a new obstruction in the visited positions of our guard, except the starting position of the guard. And we're supposed to figure out how many different positions could you choose for this obstruction. So my answer was 1,530. Now let's go to that code, guys. So guys, you can see we have the same code format. Nothing much has changed. The only thing we did was to just get migrate part 1 solution into a function. So we just find each visited positions that are like the total number of positions that the guard has visited, and we store it in our visited positions list, right? So you can see it right here. And then, guys, we then iterate through each of our visited positions. So you see we have the visited row and the visited column right here. And we check if the visited row is not equal to the starting position of the guard. since the guard is always here, guys, show you the guard is always here, so we can never place an obstacle at our starting position of our guard. So therefore, we essentially check if I defined a function called guard loops, and I check if the guard loops, so if this function returns true, we increment the obstruction count by 1. So, but before I do that, guys, I essentially check if the visited row is not equal to the guard row, or the guard column, which is the starting position of our guard. Then, if it is not equal to our guard starting position, then we set that visited row at that visited column index equal to a hash, which will be our new obstruction. Then we call our guard loops function. If it returns true, we increment our obstruction count. And then, guys, we just reset our visited row and visited column. We set it back to a dot like right here, guys. So, and then we just keep repeating this while iterating through all the visited positions. So this is what my guard loops function looks like. So I have a list of the obstruction positions that we visited, and I have an integer of the current direction we are at. I have a variable called loops. You can see it is a Boolean value. And then, guys, I essentially say in new row equals to the current guard row plus the directions at current direction index 0. So I defined the directions up here, guys, as a static variable or static array. And the new column I just increment it by that current direction based on the number that we're supposed to increment our column by. Then I check if the new row is less than or equal to map.count minus 1. This means if it's less than or equal to the edge of the map, or it's greater than or equal to 0, which is at the starting column for the map, or the starting row for the map, and we do it for the column as well. Then we check to see if our new row at our new column is equal to hash, which is an obstruction or a wall. So you guys can see it here. And then, guys, I defined a function called obstruction position visited. So it accepts our guard row, our guard column, and our current direction. Now we check if our guard row is already in our obstructions list, then we return true. Otherwise, we return false at the end of our loop. So if this function returns true, guys, that means our guard loop. So we set this flag right here to be equal to true. Then we break, which means we'll just return true from our function. And then, guys, we say, so right here, guys, we just set our guard row equals to the new row minus directions current direction index 0. So instead of moving our guard like right here, guys, we set it equal to like equal to we essentially set the guard row to be exactly at the underneath the wall, or yeah, next to the wall or whatever, and we do it for the column as well, and then we just append our guard row and our guard column to our list. Then we append our current direction, and then guys, we just change our direction once we find an obstruction. So we set our current direction equals to current direction plus 1 mod 4. So it keeps getting reset, guys. Since whenever we're looping, we're going like up, right, down, left, vice versa. So we just have 4 directions, so it just keeps resetting. Then we set our new row equals to our guard row, and our new column equals to our guard column plus the directions at our current new direction. So once we've changed our direction, guys, we just set it incremented by that column count, whatever. And then now, guys, we say otherwise if this condition up here is not true, like we're not at an obstacle, then we set our guard row equal to our new row, and our guard column equal to our new column that we calculated right up here. Then we say if our new row is less than 0, that means we're outside of the map, or our new row is greater than our map count, or our new column is less than 0, or our new column is greater than the column size, then we just break. This means that no looping happened, guys. So our function would just return false in this case. The reason for this list underscore destroy is because we allocated memory on the heap in our list, so we needed to free that memory. And then now, guys, that is how I solved the problem. So let's move to our challenge 2, and I'll run the code, and you guys can see we get 1530 for our answer. And so thank you guys for watching, and I'll see you soon for day number 7.